In this lab, we're going to work with C groups and the various tools that can manipulate and change settings for individual C groups. We're going to start by installing some utilities that will be used in our lab. So as root, we're going to run a zypper non-interactive in of the CPU set utilities. This will include the CSET tool, which we'll be using extensively in this particular lab. So if we do, now that we've got that installed, a CSET shield to give us an idea if any shielding is on. As you can see, there isn't any going on, so we're good. We're ready to move forward. So let's start by setting up a new C group. So CSET, set-C, we're saying use processors 1 through 3, and we're going to put it in a C group called CPU set 1. Okay, so we've created that, and we can do, to see what available C groups are out there, we can do a set list, and this will tell us we have our root one, and then of course a CPU set 1, which we just created. Notice that it also lists the CPUs that are being used. We can see that here under the CPU column. The root one is using all 4 of our processors on this virtual machine, and the CPU set, since we defined it as 1 through 3, well, those are the CPUs that are being used for it. Now, we're going to check, because of the NUMA architecture out there, you need to know whether NUMA is engaged while you're working with C groups. So if we do a NUMA CTL hardware, this will tell us whether it's out there and functioning. Only node 0 is available, so this means that we don't have NUMA on this particular environment, in this environment, so we don't have to worry about NUMA specific functions. So let's come back and take a look. In the sys fs C group CPU set, we can see CPU set 1 is listed there as a directory, and as a result of that, if we look at the contents of one of the files down below, we can see the assigned CPUs for that. Although we could also see it with that CPU set list command, just a different way of doing it. So if we do a cat of the sys fs C group CPU set 1 and CPU set.cpus like this, it tells us 1 through 3. Okay, so when we're working with scripting and stuff, there are tools that can go and grab this content out of these files, and we can work with that. Now, what if we want to change some values for CPU set 1? So we want to change the C group. Now, all we're doing right now, we haven't put any processes into our CPU set 1. We've only defined the parameters that are going to define that C group. So we'll look at that stuff later. But for now, let's just look within this. If we do a CSET set-s CPU set 1, we're going to create a new one. Oh, whoops. Before we do that, let's actually just change it. So set-c 1 and 3, right? So we're going to change the CPU numbers from 1, 2, and 3 to just 1 and 3. That are being used by the CPU set, and then we have to tell it which CPU set. Okay, so now if we do a C set -L, that would be the same as -- list that we did previously. But if we do -L, you'll see that 1 and 3 are now being used instead of 1 through 3. Okay, so that gives us some idea of how to interact with it. Now, of course, we could go back and take a look at this CPU set.cpus, and we see 1 and 3. So let's rename our subsystem, CPU set subsystem, and make some changes, and then we're going to interact with the processes there. So if we use a CSET set-s CPU set 1, and we give it a name of new CPU set, then it goes ahead and it performs the rename for us. Okay? And now if we do a CSET set L for list, you can see that that CPU subsystem has been renamed to new CPU set. And if we take and combine applications inside of this and use this as part of our C group, we then have access to the limitations and the capabilities that are defined here. So that's renaming it. Let's just go ahead and delete it. Let's say we don't need it anymore. It would be a CSET-D on new CPU set. Whoops. I'm sorry about that. It's CPU set like that. Okay. And it goes ahead and removes that item out of the system. That's gone. So if we do a CSET set list there, we can see that we only have the root one. Okay. And that's what we want. We're going to create a new CPU set. We're going to call it top set. So CSET set-C 1 through 3 if we wanted to. And then we're going to give it a new name. We're going to call that name top set. Okay? So we created a new set called top set with CPUs 1 through 3, very similar to what we were looking at before. Now, we can also create what are called a subset, or something below the top set, inheriting the capabilities and functions of the previous or the hierarchical set. So if we say we're going to create a CSET set-C3, which CPU? Only CPU 3, and we're going to call it top set subset 1. Okay? So we've created a new CPU set down below, and we can do something like CSET set-L-S because we're looking underneath the top set, and we can see the top set and the CPU set are a subset 1. Okay. All right. So we can see that. We can see the results of it. You can also use another command instead of specifying that you want to see what's inside the top set. If there are any subsets defined, you can use a recursive list. So CSET set-L-R, and as you can see, it tells you the path and it includes everything. Okay, so at the top we have the root CPU set, and then down below that we have additional items as well to work with. So notice, and this is interesting, if we do a CSET set-D for delete and we say top set, it says, hey, I can't do that unless you either delete the ones that are underneath or you use the recurse item when you're doing the deletion. So let's use the recurse option in order to get that. So CSET set-recurse -D on top set. And now it says, oh, wait, are you sure? In other words, you have to use recurse and you have to use the force. It's just to keep you from accidentally deleting them without meaning to. Okay, so we've got several pieces already built there. Let's take a look now at a couple other threads and processes that we can work with the CSET proc subcommand as well. So we're going to create 2 new top-level CPU sets. We're going to call them test 2 and test 3. And we're going to give them processors 1 and 2 for test 2 and processors 2 and 3 for test 3. So they're going to share one CPU. So how would we do that? Well, if we do a CSET set-C of 1 and 2, and we use that for test 2, so we've got 1 created. So CSET set-C 2 and 3 for test 3. Okay, there we go. Now if we do a CSET set-L-R, we will see all of those available to us. Okay, we got 2 and 3 in there. All right, so let's take a look at the processes in the root set. So we can use the CSET proc command and -L-S and root, and what it shows us is all of the CPU. Let's expand this out so we can see it a little bit better. But what we're seeing is, let me redo that just to give us a little better perspective. So these are all of the processes that are running in the root set. Now, if we do a CSET proc -L-S on test 2, what are we going to see? Nothing, because we haven't put any processes into that CPU set as yet. We can check the same thing for 3. So let's clear this and let's do a CSET proc, instead of -L, we're going to do S, test2, and we're going to put inside of it a bash shell. Okay, so if you look at the return, it tells us we have put a process with process ID 445 inside of the CPU set defined as test2. Okay, so now if we do a cset proc list of -S of test2, what do we see? Oh, we see exactly what we just described. We've got bash running in there as well. And you can actually see that the command we just executed against test2 as well. So we see those show up, and now we can see that we have added one in there. Let's do another one. So let's do a bash. Let's do a cset proc -L -S test2. And there we go. We actually see an additional one. Now, why did that happen? Well, when we executed this bash command up at the top here, this one up at the top, it opened a new shell. And then when we executed this, we actually saw the bash command and we see this, but we're inside of that bash command. So then when we execute bash, there's a nested bash session. So when we list it again, sure enough, we can see the additional bash in there as well. Okay, so that's executing commands inside of a CPU set, so we can assign which ones they're associated with. Now, we can go beyond that though. Instead of executing or starting a command inside of a CPU set, what if you want to move a command into a different CPU set? Well, we can do that too. So if we do a cset proc -L -S again, whoops, I forgot test2. Okay, we're just going to grab one of these. Let's take the child process ID. So that's this one, the 464, and let's move that into test3 CPU set. So cset proc -M -P 464-T test3. Okay, and now if we do a cset proc -L test3, look at that. We have successfully moved that process underneath the other CPU set. All right, so if you remember, we're just using different CPUs. That's how we've assigned this out. All right, since it was moved, it keeps the same process ID as well. Now let's move the other bash process to the root CPU set. So instead of over to a sibling, let's move it to the other CPU set, the root one. So if you do a cset proc -M -P of 445 and -T, because we're moving it to root like this, there it is. And if we were to go look, we could probably find it. But probably another way to do this is instead of doing test3, if we just look at test2, you'll notice that there aren't any tasks actually running inside of it. Okay, so we've successfully moved some things around. We've created them inside of there. Let's move an unbound kernel process from the root CPU set to the test3 CPU set. So cset, let me clear this so it's just a little more obvious. Cset proc -L root. Oh, let's actually pipe that through head and just take a look at the ones at the top there. You'll notice that right at the top, it has the list of the number of tasks running. As you can see, that's 464 tasks. Okay, we can see that value. So if we do a cset proc -K-F root to test3. Okay, so what did it do? What we said was take all of the tasks that are can possibly be moved. Actually, we just said move all of them. Move all of them to test3. And so it did that, but it complained because some of them, in this case 53, were impossible to move. And so we couldn't do that. So we can now move them back, and we probably should do that. If we do a cset proc MK force of test3 to root, we move them all back. We push them all back into their environment. And if we wanted to, we could go in, and there's a file in the etc directory. Let's just show you what that looks like. Oops. Big.conf. Oh, sorry. You have to add that. If you go in, you can you can add into a file, it's the cgconfig.conf file, you can put in how you want things arranged. Now, if you need more information on that, there's a man page for the cgconfig.conf file, and you can go in and look at that and look online. There's lots of information on it. But there you have it, working with control groups in a basic format, at least giving you an idea of how you can assign which processors to work with and how to move a process between those CPU sets so that they're grouped according to parameters that you define on SUSE Linux Enterprise.